Good evening, everyone. In today's class, we'll be concentrated or we'll be talking about the part two of this course. Now, what's the part two of this course? The part two of this course is basically talking about what the solutions to what ordinary differential equations. So basically, we'll be given an equation and we'll be asked to use one of these equations listed here to solve that particular equation given to us. Are we together? Now, in the part one of this course, we made mention of the categories and the classifications of what ordinary differential equations. So do well to go through the part one so you won't miss out of any of this content posted on our YouTube channel. Are we together? Now, under part two of this course, our interest will be what solutions to what ordinary differential equation. So here we have different solutions to solving what ordinary differential equation, and the first one which our interest will be on will be what integrating factor method, or what your integrating factor what approach to solve an ordinary what differential equation that will be given to us. So basically your work is to use this method to solve that particular what question given to us. Now the next method is what separation of variables. This is where you separate different variables. If you are given variable x and y, you do well to separate those variables before what solving that problem. Are we together? And that is your what your second solution to what ODE. Now the third solution is what direct integration method. Now in the direct integration method, you are asked to what to use what integration to solve that particular what equation that will be given to us. Are we together? Now the next approach is what we call the Bernoulli's what approach, right? The Bernoulli's what approach, or you what the Bernoulli's what method in solving your ODE equation that will be given to us. Now the fifth method, or the fifth solution to ordinary differential equation, is what we call to be our what exact solution. Now here you'll be using what your exact solution, or your exact what method in solving an ODE equation that will be given to us. Are we together? Now the last and not the least is what we call the homogeneous what method, or what your homogeneous what approach. Now here you'll be using what homogeneous method to solve what an ODE equation that will be given to us. Are we together? But in today's class, our interest will be what integrating factor. Are we together? Now we are given some questions and we are asked to use what integrating factor to solve the question given to us. Are we together? How do we use integrating factor to solve this problem? Are we together? Now I actually listed some steps that will guide us in solving problems dealing with what integrating what factor method, or what integrating factor what solutions. Are we together? Now what are the steps that will guide us in solving problems dealing with what integrating factor? The first one is to rewrite your equation to suit this manner. The first step is rewrite your equation to suit this manner. And what's the equation manner? The manner that your equation is going to look like is simply be what dy over dx plus what py equal to what q. Here this is telling you that rewrite your equation to start that equation with what dy over dx. If you are given any variable of interest, rewrite that equation to start with the differential of the variable of interest given to you with respect to what the variable of interest given to you, plus p of that variable equal to what q. Are we together? Now the next step is to compare that equation given to you with this equation to get your what py and what q. Now let's take down the first question given to us. We use that question we simplify this question using the steps given to us. Now what's the first question? The first question we're actually given, so we're actually going to a new page and we're actually changing the pen. So basically let's change the pen to black and let's go over to a new page. Now what's the first question given to us? The first question that we were given in our question list was what x minus 2, right, dy over what dx minus y equal to what x minus 2 raised to the power of what 3. That was a question given to us. What's the first thing you do? Go back to your steps. Now the first step is to rewrite your equation to suit this manner. That is, rewrite your equation such that that equation will be starting with what dy over what dx. So the first thing we need to consider in our question is to consider the variable of interest. Now the variable of interest in this question is what, basically what, y and what, x. Are we together? Now the first thing you do is rewrite that equation to start your equation with what, dy over dx. Now how do you do that? This equation is multiplied by what, dy over dx. What you have here is multiplied by dy over dx. So what you simply do is you simply divide your equation with what, x minus 2, such that you have dy over dx to stand alone. Now what you simply do is you divide here, you divide through, your equation with what, x minus 2. Now if you do that, you simply have x minus 2 dy over what, dx, right, minus y, and this will be equal to what, x minus 2 cube, right? Now the first thing you do is you divide your equation with what, x minus 2. You are dividing here with what, x minus 2, and you're also dividing this equation here with what, x minus what, 2, right? Now what do you do? Look at your common parameters. You can see that you have x minus 2 here, you have x minus 2 here as your numerator. So both of them can cancel out. What you have here, you are seeing what, x minus 2 as your numerator, you are seeing what, x minus 2 as your denominator. But note, what you have here, your power is what, invisible what, 1. Are we together? So it's almost like saying this is the same thing as having this. But what you have here, the only difference is this is raised to the power of 3 and this is raised to the power of 1. So what you do is you use one of these to cancel out one of these. Now if you cancel out one of these, you simply have 2 remaining here. Are we together? Now looking at your equation, you simply have dy over what, dx, minus y divided by x minus 2, right? And this is equal to what, x minus 2 raised to the power of what, 2. Are we together? Now look at your step given. Look at your equation. Your step given was what, rewrite your equation to suit this manner, starting that equation with what, dy over dx, right? Go back to your question. Have you started your equation with what, dy over dx? Yes. What's the next step? The next step simply says what? The next step simply says, okay, since you've started that equation with what, dy over dx, compare your py and your what, q in that given equation. Now look at your equation. How can we compare our py and q? Remember, our py is at this point and our q is at this point. So we can say that what, py is equal to what, minus, because this equation, this parameter is having this minus. So basically your py will simply be what, minus y divided by what, x minus 2. And what will be your q? Your q will be the parameter at your what, right hand side, which is what, x minus 2. So your q here will simply be what, x minus 2 all square. Are we done? No. Look at your step. Your step says after comparing py and q, get p and q. So your interest is to get just p and what, q. Remember here we know what is py and we know what q is, right? So basically we've gotten q and we know that our q in our question is simply what, x minus 2 raised to the power of what, 2. What's now your p? Your p will simply be what, you have y here, you have y here at your as your numerator here. So what you do is you simply take this to be what, over 1, such that this y here can cancel out what, this y here, and you'll be left with what, 1. So basically what will be your p? Your p will now be left with what, minus 1 divided by what, x minus what, 2. Are we together? So you succeeded in getting the value of what, q, and you succeeded in getting what, the value of what, p. Are we together? Now go over to your step. What's your step saying? After getting your p and your q, apply your what, your first if statement. So I call this your first what, if statement. Take note, your first if statement. And what's your first if statement saying? Your first if statement is saying what, take the exponential of the integral of what, p dx. So basically we are taking what, the exponential of p, and what's our p here? Our p is simply what, minus 1 over what, x minus 2. Let's go to a new page. Now the next step is what, apply your what, if statement, and your if statement simply says what, exponential of integral. So this is an exponential of integral of what, p dx. Are we together? So if you do that, you simply have this to be what? Your exponential of integral, and what's our p? Remember, our p is what? Minus 1 divided by x minus 2. So you simply have here to be what? Minus 1 divided by what? X minus 2 here dx. Are we together? Now what's the next step? The next step is actually, after getting your if statement to be what? Exponential minus 1 over x minus 2 dx. The next thing is to solve for the power of your exponential here. And what's the power of our exponential in our question? The power of our exponential is what? Integral of what? Minus 1 over what? X minus 2. So basically we are to solve for integral of what? Minus 1 divided by what? X minus 2 dx. So these are our basic these are basic integration that we have here. So what you do is you simplify this first. Simplifying this first, you have a negative sign here. Take the negative sign outside the what? The integral sign, and this will give you what? Minus integral of what? 1 divided by what? X minus 2 dx. Remember, when we were talking about elementary to what? Integration, we made mention that when we have integral of 1 over x dx is the same thing as what? This is equal to what? Ln x. Are we together? Now apply this concept here. If you apply this concept here, you can simply call what you have here to be what? X. Now if you apply this concept here, you will simply arrive at what? Remember, your minus is still outside, so you will now have minus into 1 over what? X minus 2, and that will give us what? Ln x minus 2, right? This will have ln x minus 2. What we do is we add plus c, but in this case we're not done with the integration because we still have what? Exponential here to simplify. Are we together? So what you do is, since you've solved your integral of what? Minus 1 over x minus 2 to be what? Minus ln x minus 2, impute it back into your if statement. If you impute it back into your if statement, you now have your new if statement to be equal to what? Exponential minus ln x minus 2. Are we together? Now remember, we can still simplify what is minus ln x minus 2. Remember, from the law of indices. Law of indices tells you that if you have a n b, this is the same thing as writing nb raised to the power of what? A. Are we together? Now remember, you have an invisible minus 1 here. So if you want to simplify this with respect to your indices concept here, this will be exponential what? Ln x minus what? 2 raised to the power of what? Minus 1. Are we together? Now, what's the next thing you are seeing? You are seeing what? Exponential and ln up here. Now, the concept is your exponential can cancel your what? Your ln here. So exponential is cancelling your what? Ln here. And what are you now left with? You are now left with what? X minus 2. Are we together? If you are left with x minus 2, what's that telling you? Your if statement will now be equal to what? X minus 2 raised to the power of what? Minus 1. How can we simplify this? Remember, when we have minus 1, that's telling you that this is raised to the power of what? This will be what? 1 divided by x minus 2, because of what? Your minus sign here. So if you want to simplify what you have here can be written as what? 1 divided by x minus 2 raised to the power of what? 1, because this was raised to the power of 1. If we have 2 here it will now change to what? 2. But why are we not having this minus here? Why are we not having the minus again? Is because of the 1 over we raised. Because of this 1 over, that's why the minus went out. Are we together? So what you have here can be simplified to be what? 1 divided by x minus 2. So this is now your new what? If statement. Are we together? So since we've succeeded in getting your new if statement, what's the next step? The next step says what? Apply your second if statement. So basically we have two if statements when we are considering integrating factor. Now, the first one is our first if statement that talks about what exponential raised to the power of. But our second if statement just talks about what y dot if, which is the first if statement, is equal to your integral of your first if statement multiplied by what the value of what q that you got. So we can call this our second what if statement. Since we can call this our second if statement, let's go back to your question. Your question simply says what? Apply the second if statement. And what's the second if statement? The second if statement simply says what? If y dot what? If is equal to integral of what? If multiplied by what? Q dx. Now, if you want to apply this next concept here, if you want to apply this next step, the next step simply says what? What's your y? What's your y? We don't know our y because that's our interest. So since we don't know our y, your y variable stands as your what? Your y. So you simply have y dot, what's now your if? Your if is 1 over x minus 2, which we got. So you simply have 1 divided by x minus 2, and this will be equal to integral of what? If. And what's your if? 1 over what? X minus 2 dot, what's now your q? Remember, we got our q here to be what? X minus 2 square. So you simply impute this your q that you've gotten into your second if statement, and if you impute that, you simply have this to be multiplied by what? X minus 2 all square dx. So basically, this is what we have. Now, what's this telling you? This is telling you that you first simplify your right hand side, and on your right hand side, you simply have the integral of what? 1 divided by what? X minus 2 multiplied by what? X minus 2 all square dx. Are we together? Now, look up. Look at x minus 2 here. Look at x minus 2 here. Remember, this is point here, which is serving as your what? Your multiplication. We can rewrite this to be divided by 1, balancing the equation. Balancing the equation, you can simply have x minus 2 here and what? X minus 2 here. Remember, this is having an invisible power of what? 1. So what's that telling you? This is telling you that you can simply use this power of 1 here to remove this power of 2 here, and you'll be left with what? The power of 1 here. Are we together? Now, if you have that, this is simply cancelling out, and you are left with 1 of what? X minus 2 here. So what you simply do is to simplify. Simplifying, you simply have your right hand side of your equation to be integral of what? X minus 2 dx. So basically, this is what you have on your right hand side of your equation. So if you want to rewrite that in a new page, we'll simply have that y multiplied by, right? Y multiplied by 1 over x minus 2, and this will be equal to integral of what? X minus 2 dx. This is our new equation. We can simplify the left hand side of your equation to be y multiplied by 1 here. And if y multiplied by 1 here, you still have what? Y. So we simply have here to be what? Y divided by x minus 2, and this is equal to what? Integral of what? X minus 2 dx. Now, let's apply our normal rule for what? Integration. And what's the rule? The rule is, since you have minus here, your integral sign will be going into two of these parameters here, such that you will simply have integral of x dx minus integral of what? 2 dx. Are we together? So if you have this here, this is simply what you have here. If you have this, this is telling you that you are going to integrate x first before integrating what? Minus 2. Are we together? Now, if you do that, you simply have y divided by x minus 2, and this will be equal to, if you integrate x, you simply have x raised to the power of what? 1 plus 1 divided by what? 1 plus 1. That's the concept of integration. And this will be what? Minus, if you integrate a constant, you simply add what? The variable of what? Interest to that constant. And the variable of interest you are integrating with respect to is what? X. Are we together? So this will now be what? 2x plus what? C. Why are we not adding plus C? Because we are literally what? Done with our solution. That's why we had plus our constant C in this equation. Now, what's that simply telling you? Since you have this, we can still simplify this. We have 1 plus 1 here. And if you simplify that, you have y divided by x minus 2, and this will be equal to what? X squared divided by 2 minus 2x plus our constant c. Let's go over to our steps. What was our step saying? Our step is saying after applying your second if statement, solve for y. That's the next thing. The next thing is to what? To solve for y. How are you going to solve for y? The next step is telling you that, okay, after everything here, your interest is what? This value of y here. What will be this value of y? Simplify y here. But remember, your y is having divided by what? X minus 2. So what do you have? What do you do to your division here? So what you do to this division here, you simply multiply your equation with what? X minus 2, such that you have your y to stand alone. So basically, you are multiplying this equation with what? X minus 2. So you have y divided by x minus 2 multiplied by what? X minus 2, and you're multiplying x minus 2 throughout your equation. This will simply be what? X squared divided by 2 multiplied by what? X minus 2 minus 2x, which is what we have here, times what? X minus 2, and we have plus c multiplied by what? X minus 2. Now look at your equation. You can see that what you have here can simply what? Cancel out what you have here, and you'll be left with your new equation to be y to be equal to what? X squared divided by 2, this is 2 here, divided by what? X minus 2 minus 2x into what? X minus 2 plus your constant c into what? X minus 2. So basically, what is this telling you? This equation is telling you that you've simply gotten the value of your y, and the value of your y is simply what? X squared divided by 2 into what? X minus 2 minus 2x into what? X minus 2 plus what? C into what? X minus 2. So basically, what you are seeing is your values are having what? X minus 2 all true. So you can factor out x minus 2 as the case might be, such that when you apply or when you expand, you still arrive at this. But better still, you can still leave your question in this manner. So basically, you've solved your question given using what? The integrating what? Factor method to solve your first question, which was what? X minus 2 dy over dx minus y is equal to what? X minus 2 raised to the power of what? 3. Let's go over to the next question. Now, in the next question, we simply have what? Dy over what? Dx minus y equal to what? X. This is very simple. This is very simple. Now, let's attempt this question using what? The integrating what? Factor method. So the next question simply says what? Dy over what? Dx minus what? Y, and this will be equal to what? X. So what you are asked is to use your integrating factor to simplify what we have here. We already know the steps offhand. We already know the steps, right? So let's use the steps to solve this particular problem. Now, looking at our problem, the first step is to rewrite your equation to suit what? This manner. And what's that manner? Dy over dx plus py is equal to what? Q. Looking at our equation, is our equation not suiting that manner? Yes, it's basically what? Suiting the manner that was given to us, which is our equation is starting with what? Dy over dx, and we simply have what? Y, which is standing as our what? Py, and we have x, which is standing as our what? Q. So the next thing is to compare. Comparing, we simply have py will now be equal to what? Minus y. So here we have minus y here, right? Now, the next thing is to get your P. What's your P? Your P simply says what? Make what you have here to stand alone. Make P stand alone. Divide here by Y. Divide here by what? Y. Y is cancelling Y here, and you're left with what? P to be equal to Y is cancelling this Y, and you're left with what? 1, right? So you simply have P to be what? Minus what? 1. Now, what's your Q? Your Q is your X here. So basically, your Q is the value you have at the right hand side of your equation, which is what? X. Are we done? No. The next thing is to apply your first if statement. That's the next step. Apply your what? Your first if statement. And what's your if statement saying? Your if statement is saying what? if is equal to exponential integral of what? P dx. Right? We've already gotten P here to be what? -1. So we have our if statement to be equal to what? Exponential integral of what? -1 dx. Now, the next thing is to solve for your integral here. Solving for your integral, we are simply solving integral of what? -1 dx. Now, look at your integral here. You're having integral of a constant. You can take this minus outside. You simply have this to be what? Minus integral of what? 1 dx. Are we together? Such that you are solving this constant given. So if you integrate a constant, you are simply having what? The variable of integral that you integrate with respect to. And what's that variable? X. So we simply have this to be what? Minus what? X. Since we've simplified what our integral of -1 dx, and we said our integral of -1 dx is simply what? Minus x. Let's impute minus x into our if statement. If you impute that into your if statement, you simply have if will now be equal to what? Exponential minus x. Are we together? Now, what's the next step? The next step is apply your second if statement. That's the next step because we've already solved for integral of p dx. The next thing is to apply our second if statement. And what's our second if statement? Your second if statement simply says what? Y dot if is equal to integral of what? Integral of if dot what? Q dx. That's our second if statement. We already know what our if is, right? So we are to look for y. So your y multiplied by your if, which is what? Exponential minus x is equal to integral of what? Exponential minus x multiplied by what's your q? Your q here is x. So you have x dx. The next thing to do is to rearrange your equation. Rearranging your equation is actually, we are simplifying, we are simply going to rearrange the equation such that we can integrate the right hand side of your equation. If you rearrange this equation, you simply have y exponential minus x, and that is equal to integral of what? X exponential minus x dx. Now look at your right hand side. You are asked to integrate what? X exponential minus x dx. Remember, what we have here is a sign that this is what? Integration by what? Part. You can only use integration by parts to integrate what we have here. We cannot say integral of x dx, integral of what? Exponential minus x. Never. We don't do that here. But what we do is, when we have something like this, we call it the integral of what? Of a polynomial and an exponential. The polynomial here is what? 1. Polynomial is 1 here. The exponential is what? Exponential minus x. So you apply the integration by part concept, and which says what? Integral of what? U dv is equal to what? Uv minus integral of what? V du. This is the concept of what? Integration by part. Such that from what we have here is the same thing as what we have here. So basically, integral of what? U dv is the same thing as integral of what? X exponential minus x dx. From what we have here, the first thing you do is to identify what your u is and what your dv is. So basically, your u is the polynomial which you have there to be x. So you have u is now equal to what? X. The next thing is dv. What's your dv? Your dv will now be what? Your exponential, which is exponential minus x, right? Now look up. We said that your u dv is equal to uv minus v du, which is the concept of what? Integration by part. So what's this telling you? That your interest will be what? U v du. Are we together? Now, how do you get v? To get v, you have the v over what? Exponential minus x. This is telling you that you've differentiated what? V. And since you've differentiated v, you've gotten what? Exponential minus x. What do you do to get what? V. You simply what? Integrate both sides of your equation. If you integrate both sides of your equation, you simply have the integral of what? The v is now equal to the integral of what? Exponential minus x. Are we together? If you do that, You will simply have your d here cancelling your integral sign and you are left with what? V. And your V will now be equal to what? If you integrate an exponential minus x, you simply have minus exponential what? Minus x. Are we together? Now, what's the next thing? The next thing is to get what your du is. Du simply says what? Differentiate what? U. So we are going to differentiate u here. If you differentiate u with respect to x, you will simply have your du to be equal to what? 1. Are we together? So you succeeded in getting the parameters of interest, which are your u, your v, your du, and your what? And your v. Are we together? So what you simply do is you take your parameters of interest, you impute it into your integration by part concept to arrive at a certain answer. Then we are imputing the answer into what we have here. Are we together? Let's go into a new page. Now, if you do that, you are simply replacing those parameters with what we already have there. So what's your u? You go back to your question. Your u is simply what? X, right? So we use x to represent our u here. So if you come back here, you simply have this to be equal to, we know our u to be x, multiplied by, what's your v? Go back to what you have. You have your v to be what? Minus exponential minus x, right? So you go back to your question, you have your v to be minus exponential minus x. The minus here will come, then we now have integral of, your v was what? Minus exponential what? Minus x, and your du, we had our du to be equal to what? 1. Are we together? So if you have your du to be 1, we represent your du here to be multiplied by 1. What's the next thing? The next thing that should come to your mind is this equation is what? Scattered. So what we do is we rearrange this equation. Rearranging this equation will simply arrive at what? Minus x exponential minus x minus, this minus will come out. And if this minus comes out, this will become what? Plus integral of what? Exponential minus x. Now remember, we are to integrate what we have here. Integrating what we have here, we'll simply have this to be equal to what? Minus x exponential what? Minus x plus, if we integrate this, we'll simply have this to be equal to minus exponential what? Minus x plus c. Why are we adding plus c? Because this is the end of our what? Integration. So if we have that, we'll simply simplify what we have here because we're having plus here. This plus is coming inside. If you have that, this will simply give you what? This will be equal to minus x exponential what? Minus x. Instead of having plus here, your plus is entering your bracket here. And it will now be what? Minus exponential what? Minus x plus c. Now remember, what we were calculating for was just what we have here. And we've already succeeded in getting this our parameter here, which is what? Integral of x exponential minus x. So we impute our answer. We are going to impute this answer. We are imputing this answer into this given what? Equation. Are we together? So we'll simply have our given equation. Our new equation will now be y exponential minus x is now equal to minus x exponential what? Minus x minus exponential what? Minus x plus what? C. Go back to your step. What's your step saying? Your step is simply saying what? Solve for y. So everything we've been solving for, we are trying to solve for what? The value of what? Y. What is your y? Now from your question, from your calculation, since you've gotten to this extent, what you do is you make y subject of the formula. Making y subject of the formula, you're basically dividing through by exponential minus x. You are dividing here by what? Exponential minus x. You are dividing here by what? Exponential minus x. You are dividing here by what? Exponential what? Minus x. And you are also dividing your constant with what? Exponential minus x. Such that your exponential minus x and the exponential minus x is going out. And you are left with what? Y to be equal to, now look up. You have exponential minus x here, can cancel out this. This can also cancel out this. You are left with 1 here. So your new equation will now be what? Minus x minus 1 plus what? C in divided by what? Exponential minus x. Remember what we have here, we can simplify this. Now if we simplify this, we have that our y to be our new equation which we've already proved or we've already solved, it will now be what? Minus x minus 1 plus c exponential what? X. So basically this will be the solution for our question given. Are we together? Now let's take the next example there. What's the next example saying? The next example is simply saying what? 1 minus x square multiplied by dy over dx minus xy equal to what? 1. Remember, we are to solve this using what? Integrating factor method to simplify this. Are we together? If you have questions, drop it on the comment section. Looking at the next question, we simply have your next question to be 1 minus x square dy over dx minus what? Xy is equal to what? 1. What are we asked to do? We are asked to use our integrating factor method to solve this particular what? Problem. Now, how do we go about it? What we have there is simply what? We'll simply have 1 minus x square dy over what? Dx minus what? Xy equal to what? Minus xy, and that is equal to what? 1. That's what we have there. So we have xy equal to what? 1. Now the first thing using our integrating factor to solve this particular problem is to make dy over dx stand alone. Making dy over dx stand alone, we are going to divide all through our equation with what? 1 minus x square. Now if you do that, we are dividing here with what? 1 minus what? X square. And we are also dividing 1 here with what? 1 minus x square. Such that we'll have this to cancel this and we are left with what? Dy over what? Dx minus xy divided by 1 minus x square. And this will be equal to what? 1 divided by 1 minus what? X square. Are we together? Now the next thing is to compare to get what? P and Q. Comparing your equation, we know that our py here will simply be equal to what? Minus xy divided by 1 minus x square, and we have our q here to be equal to what? 1 divided by 1 minus what? X square. What's our interest? Our interest is to get what is p and not what is what? Py. So this is divided by 1 here. So what you simply do is you cancel out y here, this will cancel out, and you are left with 1 here. So you simply have minus x times 1 is what? Minus x. And you are left with what? P to be equal to what? Minus x divided by what? 1 minus what? X square. Are we together? Now the next thing is to apply your if statement. What's your if statement? Remember, our if statement is simply what? If is equal to exponential integral of what? P dx. That's the concept. Now the next thing is to apply your if statement, imputing what? P with the value of what? P here. And if you do that, we have our if to be equal to exponential integral of what? Minus x divided by what? 1 minus x square dx. Are we together? Now look at what we have here. Look at what we have here. We simply have exponential integral of what? Minus x divided by 1 minus x square. The next thing is to solve for your integral of what? Minus x divided by 1 minus x square here. Now, if you solve for what we have there, we simply have integral of what? Minus x divided by what? 1 minus x square dx. This is what we are asked to solve for. Now, how do you solve for this kind of problem? Remember, from our elementary integration, we can call this what? U. So take note that u can be called what? 1 minus x square, such that Anywhere you see y minus x square, you represent it with what? U. Are we together? Now, if you do that, you will simply have that this will now be equal to integral of what? Minus x divided by what? U dx. Are we together? Since we have integral of minus x divided by u dx, right? What can we do? Remember, what we have here, remember we have u to be equal to 1 minus what? X square. Are we together? So we can differentiate u with respect to x. Differentiating u with respect to x, we simply have du over what? Dx to be equal to what? 2x minus what? 2x. Now look up. From what we have here, we can represent this to be du is equal to what? Minus 2x dx. Can we make dx stand alone? If we we can make dx stand alone from what we have here. From what we have here, we can make minus dx stand alone. If you make dx stand alone, you simply divide here with what? 2. You divide here with what? 2. So you are left with 2 here, 2 here will cancel out, and you are left with what? Minus x dx is equal to what? Du over what? 2. Now look at what you have here. What you have here, you can represent what you have here to be integral of what? Minus x dx divided by what? U. Apply this concept here such that you've already known what minus x dx is, and what's minus x dx. Minus x dx is simply what? Du divided by 2. So you simply have this, you simply have your new equation to look like this. You simply have your new equation in this manner. Integral of what? Minus, remember, you are representing minus x dx with what? Du over what? 2. So here you simply have du divided by what? 2 divided by, which is your long division, with your u here. But remember, what's this u here? Your u here simply stands for what? Your u here simply stands for what? 1 minus what? X square. Are we together? Now you can take out 1 over 2 from what you have here. If you take out 1 over 2 from this equation, you simply have 1 divided by 2 integral of what? Du over what? U. Are we together? Now look up. You've already arrived at what? Du over 2. This du over u, this can also give you what? 1 over 2 divided by what? 1 divided by u du. Are we together? But if you integrate 1 over x, this will give you what? Ln x, right? Apply the same concept here. If you apply that concept here, what you simply have here will simply be what? 1 over 2 ln u. But your u was equal to what? What's your u? Your u was 1 minus x square. So you have here to be what? 1 minus what? X square. Now we are representing 1 minus x square with u here. So your equation, your equation will simply be what? 1 divided by 2 ln 1 minus what? X square. Are we done? No, we are not done. We are simply taking this back to our if statement, which is what we have here. If you take this back to your if statement, you simply have your new if statement to now be if will be equal to exponential 1 over 2 ln what? 1 minus x square. What do you do? Apply the concept of what? Indices. What's the concept of indices? The concept simply says what? If you have an, if you have an, the concept simply says if you have a, what's the concept? The concept is very simple. The concept says what? If you have a n b, your a n b can also be represented as what? N b raised to the power of what? A. Apply this concept here If you apply this concept here, you simply have your if to be equal to what? Exponential ln 1 minus x square raised to the power of what? 1 over 2. Are we together? You can see that what you have here, ln can cancel out exponential, and you are left with your new if statement to be equal to what? 1 minus what? X square raised to the power of what? 1 over 2. The law of indices also say if you have a raised to the power of what? M divided by n. What you have here will simply be equal to what? Square root of what? N, a raised to the power of what? M. Apply this concept to what you have here. If you apply this concept here, you simply have this to be equal to if to be equal to what? Square root of what? 1 minus x all square. Remember, this will be raised to the power of what? 1. So there is no need. So you can still put it to be raised to the power of 1, or you can still leave your answer to be what? Square root of what? 1 minus x square. The next thing is to apply what you have here to your what? Your last if statement. And the last if statement says what? Y dot if is equal to integral of what? If dot what? Q dx. Let's apply our last if statement. If you apply your last if statement, you simply have this to be y multiplied by square root of what? 1 minus x square, because that was our if statement. This was our first if statement. And this will be equal to integral of what? What's your if? Your if statement here will be what? 1 minus what? X square multiplied by what's your q? Let's go back to our question. We have our q, we already found our q, and we said our q was equal to 1 over what? 1 minus x square. So your q here will be multiplied by 1 over 1 minus x square multiplied by what? Dx. Now our interest is to get what f is, right? Our interest is to get what? Our interest is to get what is your what? Y. So if you want to get what's your y, we'll first integrate what we have here. We can rewrite your right hand side to be equal to what? Integral of what? Square root of what? 1 minus x square divided by 1 minus what? X square dx. And this will be equal to 1 dot what? Integral of 1 dot square root of 1 minus x square. That's what we have. So the first thing we do is, if we are going to integrate what we have here. If you integrate what you have here, you simply have what? Y dot what? Integral of y dot root 1 minus x square, and this will be equal to, remember, we want to integrate what we have here. If we integrate root 1 over x square divided by 1 minus x square dx, you will simply arrive at what? Ln x plus what? Square root of what? X square plus 1 plus c. Now if you integrate that, you arrive at this. If you arrive at this, your interest is to get what y is. To get what y is, you are simply dividing both sides of your equation with what? Root 1 minus x square. So we are dividing here with what? Root 1 minus x square. We are dividing what we have here with what? Square root of what? 1 minus x square. And we are dividing here with what? Square root of what? 1 minus what? X square. Such that you will now have your y to be equal to ln 1 ln the absolute of x plus what? Square root of what? X square plus 1 plus c. Remember, this is dividing what? Square root of what? 1 minus x square, and this is dividing what? Square root of what? 1 minus what? X square. You can also do well to simplify further, but for the sake of this class, we are going to end at this point, because our interest is to what? To know what y is. are we together? Now look at the next question. Look at the next question. The next question is very easy. They said what? We are going to use integrating factor to simplify what we have here. So the first thing you do is you divide both sides of the equation with x, you divide here with what? X, and you divide here with what? X. Such that you will simply have dy over what? Dx to be equal to y divided by x. Here, x will cancel out one of these and you will be left with what? X squared. So what you do for me is solve this using integrating factor and drop your answers on the comment section.